Now we're going to talk about trigonometric ratio of special angles. In trigonometry, special angles are the 0 degrees, the 30 degrees, the 45 degrees, the 60 degrees, and the 90 degrees. Okay, even though 0 degrees and 90 degrees are not usually mentioned, but they all are special angles. You get used to 30, 45, and 60 degrees. Okay. Before we attempt the exercises, I first wanna say why all these are special, are considered as a special angles, because the trigonometric ratios of these angles can be evaluated without using a calculator. I'll prove you how. I am going to draw, I'm going to prove you how in two different methods. The first method, I'm going to use the triangle, okay? Let's see. If I draw, for instance, a right angle triangle here, okay, a right angle triangles, you know, a right angle triangle has a 90 degrees angle. That's why we put that square there. And then I'm gonna place some values here. Let's say this is like 1 unit, and then that's also 1 unit. So that makes it an isosceles right angle triangle, because they have like, it has like a pair of equal sides. Now, you know, if an isosceles, we have a right angle isosceles triangle, it implies that the angles, okay, the adjacent angles are also equal. And because one angle is 90 degrees, to have two equals angles here, those angles must be equal to 45 degrees each. Why? I'm going to tell you now. Why? Because sum of the angle in the triangle is equal to 180 degrees. So we have like 90 degrees. How do I know it 45? I want to say 190 degrees plus like, if I call this angle x, because I didn't know it, I did not know it, it's going to be like 90 degrees plus x must be equal to 180 degrees, okay? And then I do like 90 plus 2x equal to 180, and then I move the 90 over, we have like 2x equal to 180 minus 90, and then 2x will be equal to 90 degrees, and if I divide both sides by 2, I'll get x will be equal to 45. Now, that's why, because this is x, it's going to be 45 degrees. That's also x going to be 45 degrees. So that's the reason why these two angles must be 45 degrees. Okay. Then we can also calculate the missing side here is the hypotenuse. Okay. Now, we do know that the hypotenuse given by C is like C equal to square root of A squared plus B squared. Okay, we can substitute the values of A and B, you know, where A is, sometimes it's written, sometimes they write R, sometimes they write R equal to square root of X squared plus Y squared. They mean the same thing, okay? C and R here stand for the hypotenuse, this adjacent side, opposite side, okay, of the angle. Now we can substitute the values, one there, it's gonna be like, it's gonna be, C will be equal to square root of 1 plus 1, okay, 1 squared, you just make a square root of 2. So this side is equal to square root of 2. Okay, the other triangle, I want to draw another triangle. Here, I want to call this triangle, let's say I want to draw I want to draw an equilateral triangle. Okay, you know, the properties of equilateral triangle is like all sides are equal. Okay, let's put my sides equal to 2 units. Now, if for instance I draw a perpendicular bisector, okay, from the tip of my triangle to the midpoint of the triangle, let's say I'm gonna draw my perpendicular bisector over here, from the top to the bottom. I'm gonna use dashed line. We have like two triangles here. Okay, but before I continue, I proceed, let me mention that properties of equilateral, we say it's equilateral triangle because all the sides are equal, okay? Another property is like all the angles also are equal to 60 degrees, okay? Within an equilateral triangle, they're all equal to 60 degrees, the angles, and then all sides are equal. Then, if I draw a perpendicular triangle here, a perpendicular bisector, I mean, you notice that we have like a 90 degrees angle there, a 90 degrees angle there, okay? And it breaks our equilateral triangle into two identical triangles here. And then you obviously, the angles here will be like 30 degrees and 30 degrees because they amount to 60 degrees. I can redraw the triangle over here. Okay, so it's like we have like a 90 degrees angle there, and then this angle obviously 60 degrees. Okay, and there the angle is now 30 degrees because we just take half of it, and then the sides were like this was 2 units, and now because it's half, it's gonna be like 1 and 1 here, so this is gonna be 1 unit, and then this side, the vertical side, the perpendicular side is the missing side, the unknown. We need to find it. You can still use the same formula to find that missing side. So in cases like this, I prefer to write my Pythagorean theorem as c squared equal to, not square root, but now it's going to be like a squared plus b squared, okay? So we can substitute the value of c, which is 2. So it's going to be like 2 squared will be equal to 1 squared plus b squared. Now that makes 4 equal to 1 plus b squared. That makes like 4 minus 1 equal to b squared. And then that makes 3 equal to b squared. And then to get the value of b, we can just square root both sides, okay? And then that makes b will be equal to plus minus 3, but we just want to take 3 units because we consider positive sides. The sides, I mean, the length must be positive. So it's going to be 3 there. Wow, what am I saying? Square root of 3. Square root of 3 there. Then we have like all the sides of the special, all the missing sides of the triangle that has special angles. Remember, we said the special angles are these. At most of the time, we mentioned the 30, 45, and 60 degrees. We cannot have 0 degrees within the triangle. Okay. Now, let me remind that the trigonometric ratios are given by like sine of the angle. Any angle is equal to opposite. Excuse me, opposite over hypotenuse, sometimes written as y over r, and then cos of the angle is given by adjacent over hypotenuse, sometimes written as x over r, and then tangent of the angle is given by opposite over adjacent, sometimes written as y over x. Okay. Now, I want you to notice something. If, for instance, I want to work out, like, let's consider this first triangle here. I want to work out, or maybe let's start with this, the 30 degrees, okay? If we start take the 30 degrees, let's say I start with the angle, the 30 degrees angle, for instance, because it's a smaller one, I'll take sine of 30 degrees, okay? So this will be like opposite over hypotenuse, okay? 30 degrees is over here. Opposite side 30 degrees is this side, 1, okay? So it's gonna be like 1 over hypotenuse, which is 2, the longer side of the triangle, okay? We got it that, so sine of 30 degrees is equal to a half. You can check that in the calculator. Let's see if I do sine of 30 degrees. Okay, sine of 30 degrees, this is equal to a half. You see, we find the value of this special angle, the 30 degrees, without using a calculator. Okay, we can also continue by doing like sine of 45 degrees. Let's see, sine of 45 degrees. 45 degrees, I have it here, I have it there. I can select which angle I want to take. Let me take this one. Okay, opposite that 45 degrees is 1 here. Okay, so it's going to be like 1 over hypotenuse, which is root 2. Now, let's see if I do that in the calculator. Sine of 45 degrees. 45 equal, oh, I have root 2 over 2. But it was supposed to be a half 1 over root 2 here. But that's root over 2. So I did wrong. I made a mistake. No, I didn't make a mistake. Okay. The calculator rationalized the answers automatically. Let me prove it to you. If I have like 1 over root 2, I times it by 1. Okay, if I times it by 1, it's still going to be 1 over root 2 because anything times by 1 is just that number. But there are many ways of writing 1. Okay, I can write 1 like this, root 2 over root 2. Okay, because I know that root 2 over root 2 is just equal to 1. Okay, why I select root 2? Because I have a root 2 at the denominator here. You know, in mathematics, you don't divide by an irrational number because the irrational number has a decimal part that never ends. You know, you cannot divide something by something that never ends. For which decimal part is non-terminated. Okay, so you cannot divide by any rational number. So we rationalize by timesing by root 2 like this, and then we know that this will be what 1 times root 2 just root 2, and then root 2 times root 2 is 2. This is the same answer that we get in the calculator here. So the calculator rationalizes it by us for us automatically. Now let's take the 60 degrees. 60 degrees is over there. Let's say sine of 60 degrees. Let's see how much it will be. I'll look here. 60 degrees is there. Opposite 60 degrees is this angle. Okay. And then hypotenuse is the 2. So it's going to be like root 3 over 2. If I check the calculator, sine of 60 degrees, let's see. 60 degrees equal to root 3 over 2. So we can get the trigonometric ratio of these special angles, the 30, 45, and 60 degrees, just by knowing drawing these triangles. Okay, we draw these triangles, and then we know the value. We can find the same will be applied for cos theta, tan theta. I will let this for you to practice. Okay, so you'll find out that cos of 30 degrees, or maybe we can just check it now. Cos of 30 degrees, let's say, cos of 30 degrees will be I remove this. Cos of 30 degrees, 30 degrees is there. Okay, that's the angle 30 degrees, and then it's adjacent over hypotenuse. Adjacent side is this one. This side is adjacent to the angle 30. So it's gonna be 30, actually root 3 over 2. Okay. If we check in the calculator, cos of 30 degrees equal to root 3 over 2. You see, without using a calculator, we can do that. Cos of 45 degrees. Now let's see, 45 degrees there, and there. If I take, let's say this one, okay, adjacent side is 1, and the hypotenuse is root 2. So it's gonna be like 1 over root 2. We will rationalize as we did here, and then this gonna be like root 2 over 2. So let's check. If I do like cos of 45 degrees, is √2/2 as here. Now we can also check cos of 60 degrees. Okay, 60 degrees here, this is the angle, 60 degrees, and adjacent side to 60 degrees is that one, and then over hypotenuse, which is 2. We can check in the calculator. Cos of 60 degrees, you're gonna get it a half. Cos of 60 degrees equal to, you see, a half. So without using a calculator, we can find these trig ratios. We can also do the same with the 10. Okay, let's check. 10 of 30 degrees is what? Okay, 10 is opposite over adjacent, as the formula indicates here. Okay, y over x or over a. So 30 degrees. So if my angle is excuse me, the angle is 30 degrees here. Okay, that the angle opposite the angle is this one. So it's gonna be like 1 over adjacent. Adjacent is this one. This adjacent to the angle, √3. So 1 over √3. And then if we rationalize, it's going to be as we did over here, root times by √3 over √3, and then this will be equal to √3/3. You can check 10 over 30 degrees equal to √3/3. Okay, without using a calculator. So 10 of 45 degrees, it's gonna be like opposite. 45 degrees, if I take this one, opposite is gonna be 1 over adjacent also 1. I look here, 45 degrees, opposite is 1, and then adjacent is also 1. 1 over 1 is 1. Okay, so you can check 10 of 45 degrees equal to just 1. You see, without using calculator, we can get it. So 10 over 60 degrees, we can also do that. This is going to be like 60 degrees is here, opposite is √3, adjacent is 1, so it's going to be like √3/1, which is just √3. Okay, just √3. So you can check 10 of 60 degrees. 60 degrees is just equal to √3. Okay, this is the first method I wanted to show you. Okay, by using these special triangles. Okay, but now I have another method that I don't usually teach at school. I am going to write values like, be careful here. Look at the trick carefully. I'm gonna write values like 0, 1, 2, 3, and then 4. Okay. Then I am going to square root each of these values. Okay, I'm gonna square root each of them. Look, listen to the steps. We square root, we square root, we square root, we square root, and then we square root. Then I am going to divide each of these by 2. I divide here by 2, I divide by 2, I divide by 2, I divide by 2, and I divide by 2. Then the values will be equal to what? It's going to be like 0, 1, √2/2, √3/2, and then, sorry, 1/2 here, and then 1 there. Now, note this. I am going to write now all the special angles, all of them. Change the color here. I'm gonna write here 0 degrees. Or now, okay, before I do that, I want to notice that if I write sine over here, okay, I'm gonna write the special angles for sines, okay, in order: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Those are the values of sine of 0 degrees must be 0. Sine of 30 degrees will be a half. As we can see there, sine of 30 degrees was a half. Sine of 45 degrees is √2/2, as you can see there, √2/2. Sine of 60 degrees would be √3/2, as you can see, √3/2. And the sine of 90 degrees is 1, but it wasn't in triangle. You can check it yourself here in the calculator. Sine sine of 90 degrees equal to 1. You see? So those values are the values of the special angles for sine. Okay, when I go this way. Now, what else can I do here? What about cos then? For cos, I can then reverse the order. So I'm gonna write cos over here. So I'm gonna write the special angles, okay, all of them in a still this time in descending order, like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You see? So this means that cos of 0 degrees is 1. You can check the calculator because we didn't calculate the triangle. Let's check here. Cos of 0 degrees is equal to 1, you see? And then cos of 30 degrees, is root 3 over 2. You can check here. Cos of 30 degrees root 3 over 2, you see? And then cos of 45 degrees is root 2 over 2. And then cos of 60 degrees is a half. And cos of 90 degrees will be 0. We can check cos of 90 degrees there. 90 degrees will be equal to 0. So this is how we can get the special values for sine and cos. Now, what about the 10 then? What can we do to get 10? All right, don't panic. We can still make it. The 10, for the 10, you know, the formula says that 10 of the angle is equal to sine of the angle over cos of the angle. We can just take, like if I need to find 10 of 0 degrees, I will say sine of 0 degrees divided by cos of 0 degrees, which is 1. So 0 over 1. Cos of 10 of 30 degrees, I want to say sine of 30 degrees divided by cos of 30 degrees. Okay, let me take an let's start. I want to say I want to take 10 over here, and then this will be like, if I want 10 over okay, let's say if I want 10 over 0 degrees, I'll say sine of 0 degrees over cos of 0 degrees, and this will be like 0 over 1. Okay, because sine of 0 degrees is 0, and then cos of 0 degrees is 1. So 0 over 1 is going to be 0. You can check that in the calculator. 10 of 0 degrees equal to 0. And then it is so for all the angles. Okay, so I'll let you try yourself 10 of 30 degrees, of 45 degrees, of 60 degrees, and 90 degrees. For sake of illustration, I think I need to do 10 of 30 degrees also. 10 of 30 degrees, it will be like, you look at sine of 30 degrees, which is a half. So you write there a half over cos of 30 degrees. Cos of 30 degrees root 3 over 2. So root 3 over 2. Then you know that when you have a fraction of another fraction, what we do, we're going to multiply the first fraction by the inverse of the other fraction. And then this will be, when we multiply, you know, as we learned in previous grades, this is going to be 1 over root 3. And then this, we can rationalize this when we times by root 3 over root 3. And then the answer here will be just root 3 over 3. That's the 10 of 30 degrees, root 3 over 3. Remember, we did find it here. 10 of 30 degrees is root 3 over 3. So you can try get for the 45 degrees, the 60 degrees, and the 90 degrees yourself. Thank you.